Part 1. The General Theory of Relativity. You have to understand what Newtonian mechanics of gravity is and the differences between Einsteinian gravity and Newtonian gravity. Einstein's theory of relativity has said that nothing can exceed the speed of light. There's the universal speed limit. Hence, Newtonian gravity is different from Einsteinian gravity, as Newtonian gravity has instantaneous effect on other matter, while Einsteinian gravity only propagates only at the speed of light. So why is speed capped at the speed of light being the limit? All particles move or swim through a universal field which is called the Higgs field, where particles acquire their mass. Different particles interact with the field with different strength, therefore different mass. Photons, the light part, does not interact with the Higgs field at all, therefore it moves with a faster speed. Therefore, to accelerate the particle to light speed, according to the equation E equal mc squared, where energy is proportional to mass and F equal ma, and the fact that when particles get faster and faster, the mass gets heavier and heavier. So by the time it reaches light speed, there's infinite mass, which is not possible as you need infinite amount of force to accelerate a particle of infinite mass. Also, Einstein's general theory of relativity also states that any matter that has mass curves the space-time around it. Increase in mass, increase curvature of space-time. Space and time are actually interrelated, unlike what Newton told us about the mechanics of gravity, and this brings me to my next point. Part 2. Evidence of expansion of the universe. Einstein came up with the equation, curvature of the universe equal energy or momentum of the universe. It was however later omitted when Edwin Hubble discovered that galaxies are moving away from us by discovering how redshifted the stars he observed has become. This led to Hubble's law where redshift or the recession speed is proportional to distance. Hence, those which were 2 times more away were moving 2 times faster. Hence, the universe was accelerating. Contrary to what people in the olden days believed, we are actually not in the center of the universe. Just because the galaxies are moving away from us does not mean we are at the center, as we could be here or here or here or here or here. Since the universe was expanding, there was a flaw to the equation of the curvature of the universe equal energy because it didn't take into account the fact that the universe was expanding. So the cosmological constant was put in the equation where the curvature of the universe minus the cosmological constant equal energy or momentum, where the cosmological constant represents a geometric property. This can be rewritten as curvature equal energy plus cosmological constant. Now it is an energy. What this represents is something called dark energy. Now that we've established that the universe is expanding, will it expand forever? Action of gravity is acting on it. If the density was large enough, then the expansion would stop and the universe would collapse in a model called the Big Crunch. This is the model for the closed universe. Now, there are 3 types of possible universes. One is closed, one is flat, and one is open. This is where general theory of relativity comes in, which tells us that space is curved in the presence of an object with large mass. So a black hole curves light coming from behind it. However, it was found that light also curves in the presence of empty space. Therefore, cosmologists deduced that empty space did indeed have mass, and this was called dark matter. And this dark matter makes up most of the mass of the universe. Now that we know what is dark energy and dark matter, the density determining the shape of the universe and thus the future is called the mass density. Mass density is equal to the mass density of all bionic mass plus dark matter plus mass density of relativistic particles such as light and neutrino, as well as the mass density of the dark energy or the cosmological constant. Bionic mass is the mass of all galaxies, stars, rocks, and planets. And the critical density is equal to the density required to make a flat universe. So the parameter omega is equal to the mass density over the critical density. If omega is equal to 1, the universe is flat. If omega is less than 1, it is equal to be an open universe. And if omega is bigger than 1, it is a closed universe. We have already accounted for what happens if the model is a closed universe, but for an open or flat universe, the universe will expand forever, but this will lead to the heat death of the universe. Or more commonly known as the Big Freeze. This scenario is where everything moves with such speed that galaxies are so far away from each other until, in an isolated system, the entropy will increase until it reaches a max value where allowing no room of usable energy as all heat is evenly distributed, so the universe will be extremely cold. And this scenario and the Big Crunch depends on the shape and the density of the universe. That is why. This brings me to my next point. Part 3. WMAP, Cosmic Microwave Background and Discovery of what the shape of the universe is. Now, we have to find the curvature of the universe to determine the shape and thus the future. To do that, we need a triangle. If omega is equal to 1, the universe is flat. So the sum of the degrees in the triangle is 180 degrees. So Euclidean geometry applies. And if omega is bigger than 1, the sum of the angle is bigger than 180 degrees, similar to that of the Earth, as it is a closed universe. So Euclidean geometry no longer applies. And if omega is smaller than 1, the sum of the angle is less than 180 degrees. So to measure the universe, you need a triangle from one point of the universe to another. Thus, we have the WMAP. Firstly, WMAP mission has provided the first detailed sky map of the microwave background radiation in the universe. So what is the cosmic microwave background? It is the background radiation in the microwave region of the spectrum, which is observed in all directions in the sky. To understand what this means, you must first have basic understanding of the concept of black body radiation. Black body radiation is a body that absorbs all electromagnetic radiation, for example light, and strikes it. But to stay in thermal equilibrium, it must emit radiation at the same rate as it absorbs it, so a black body also radiates. Any body at any temperature above absolute zero will radiate. The intensity and frequency distribution of the radiation depends on the detailed structure of the body. Therefore, the cosmic microwave background shows that the wavelength dependence of a black body radiation is at about 3K temperature. Kelvin. It is so that remnant emitted at the point where the expanding universe became transparent. But beyond that is opaque, so the black body radiation is seen as a remnant of the transparency point at which the expanding universe was about 3000 Kelvin, so radiation could escape. So we can look very far back into the past where light started to travel in the primordial time, and the WMP AP mission detected it and gave a much better picture of the cosmic microwave radiation. Thus, the data for the round figure of 10 to the power of 9 photons led to the conclusion that no galaxies and stars could have been formed until the temperature dropped to below 3000 K Kelvin. Stars and galaxies form when the radiation pressure is less than the gravitational attraction. Beyond the point where it was 3000 K, we can't see that, and this is the wall of the universe, or the last scattering of the universe. And the age of the universe at this point was only 380,000 years after the Big Bang. This is why we can't see the Big Bang, even though light travels to our eyes from galaxies billions of light years away. So if we look far enough, we can see the Big Bang, right? Wrong. Because light has been traveling since 13.8 billion years ago, this is not true. We look further back and further back in time, temperature increases and increases and increases. It is hot enough to break apart atoms into protons, electrons, and thus the charged plasma, which is opaque. This is called the wall of the universe. Light bounces off the wall and is radiated back so we can see it. The heat scattering is the wall. Radiation that comes from the cosmic microwave background is the afterglow of the Big Bang. So we can make a massive triangle to measure this massive curvature of the universe. And the boomerang experiment showed that the universe is indeed flat, and there's zero total energy, so this could have begun from nothing. After some calculations, what the WMP found out was summarized to be the universe was 13.7 billion years old with a margin of error of about 1%. The content of the universe is 4% atoms, 23% cold dark matter, and 73% dark energy. For the model which fits our data, the universe will expand forever, so the density parameter is measured to be 1.02 plus minus 0.02. However, if the dark energy of the quintessence changes, the conclusion may not be true. Having taken into account the big freeze and the big crunch, let's take into account when the universe is flat, there are many cosmological hypotheses. The big rip is one of them, and this is when the universe and distance between the universe at a certain time in the future will become infinite. This relies crucially on the type of dark energy when things are so far away from each other that the observable universe becomes smaller than any particular structure. No interaction by any of the fundamental forces, gravitational, electromagnetic, weak and strong nuclear forces can occur. Big rip happens and there will be a final singularity like a black hole where all matter will divide into two and all distances will diverge to infinite value. Singularity is a region of space where the density of matter or the curvature of space-time becomes infinite and the concepts of space and time cease to have any meaning. At this point, the whole fabric of space-time ruptures and the precepts of Einstein's general theory of relativity breaks down and no longer applies. However, the big freeze seems to be the most likely possibility. In this scenario, the universe continues expanding and gradually runs down to a state of zero thermodynamic free energy in which it is unable to sustain motion or life. During a timescale of 10 to the power 14 years or more, we reach a maximum entropy at a temperature very close to absolute zero. All matter will slowly evaporate away, leaving only black hole as the universe is continuing to expand. However, even these massive giants are not immortal and will eventually break down from Hawking radiation. The Hawking radiation is a state when random and featureless subatomic particle and thermal radiation predicted to be emitted through quantum effect over long periods of time. Black hole loses more and more mass and shrink and eventually disappear from sight. Protons and neutrons start to decay into positrons and electrons, which of course being matter and antimatter will eventually annihilate each other over a long period of time, and this will mark the end of the universe. Part 4. The Thinking Adventure. Since the effect of gravity cannot exceed the speed of light, a hypothesis will be this. If you were a huge lump of matter the size of the universe, you wouldn't know that you have a massive amount of gravity because effect and information cannot travel faster than light.
Part 5. The concept of nothing being something.
According to laws of quantum mechanics, nothing is not really nothing. It's actually virtual particles popping in and out of existence in a very small scale. Most of the mass of protons come from empty spaces and not the quarks in between. So here's a philosophical question. If there's nothing, why is there something? And did the universe come from nothing? And because of quantum fluctuations, no total energy as a result of negative and positive energy balancing each other out. So what was the beginning? So did the universe come from nothing? Just quantum fluctuation? Just a matter of luck? Did it come from a creator? And this will lead to my closing remarks.
Part 6. Closing remarks.
Now, the anthropic principle is a philosophical consideration that the universe was made for us to observe it. And it appears that there is a set of fundamental physical constant that if it had been tweaked a little, the universe will have been void of intelligent life. So, is the universe fine-tuned for us intelligent beings? If there were higher or lower cosmological constant, it wouldn't have existed. So is it coincidence that the universe was just exactly right, which led to our existence? And this leads to the question, is there a creator or multiple universes that are different? And this is just a cosmological evolution. And this is why the universe gave life to us, to find out the true identity of itself, the universe.